Hello, I am Gopakumar. Welcome to your math tutor. Here we focus on helping you to solve the problems in engineering mathematics in the easiest possible way from an exam point of view. If you are interested in theory, then check out NPTEL. Evaluate integral minus infinity to infinity cos x by x square plus 1 the whole square dx. In case of contour integration, generally the most critical aspect of solving the problem is identifying the type of the given question. Here in this question, minus infinity to infinity cos x by x square plus 1 the whole square dx, limit varies from minus infinity to infinity and it is in the form of integral minus infinity to infinity f of x by g of x cos ax, where f of x and g of x are polynomials such that degree of g of x exceeds that of f of x. Therefore, this question comes under type 3. Another important thing to note here is, if the question is of type 3, we consider only the poles which are above real axis, that is, we have to find the residues of only positive poles. We know that e raised to ix equal to cos x plus I sin x. Cos x is the real part of e raised to ix and sin x is the imaginary part of e raised to ix. Integral minus infinity to infinity cos x by x square plus 1 the whole square dx is equal to integral c. Cos x is the real part of e raised to iz by x square plus 1 the whole square becomes z square plus 1 the whole square. Here the poles are given by z square plus 1 the whole square equal to 0. Then z square plus 1 equal to 0. Then z square is equal to minus 1. Taking square root on both sides, we get z is equal to plus or minus root of minus 1, which is equal to plus or minus I. Then we get the poles z is equal to I and z is equal to minus I. Only z is equal to I lies above real axis. In type 3, we have to find the residues of only the poles which are above real axis. F of z equal to e raised to iz by z square plus 1 the whole square becomes z plus I into z minus I the whole square. In f of z, the power of the denominator is greater than 1. Then to find the residue of z is equal to I, use Cauchy's residue formula for pole of order m. 1 by m minus 1 factorial into limit z tends to a d raised to m minus 1 by dz raised to m minus 1 z minus a whole raised to m f of z. Since f of z is e raised to iz by z plus I the whole square into z minus I the whole square, then we get m is equal to 2, a is equal to I. Substitute m is equal to 2 and a is equal to I in Cauchy's residue formula. Residue z is equal to I, f of z equal to 1 by m minus 1 factorial becomes 1 by 2 minus 1 factorial. Limit z tends to a is I, d raised to m minus 1 becomes d raised to 2 minus 1 by dz raised to m minus 1 becomes dz raised to 2 minus 1, z minus a whole raised to m becomes z minus I whole raised to 2. F of z is e raised to iz by z plus I the whole square into z minus I the whole square. Cancelling z minus I the whole square terms, we get 1 by 1 factorial into limit z tends to I d by dz of e raised to iz by z plus I the whole square. Differentiate e raised to iz by z plus I the whole square using quotient rule. Then limit z tends to I, denominator into derivative of numerator e raised to iz, which is e raised to iz into I, minus numerator into derivative of denominator z plus I the whole, which is equal to 2 into z plus I. Whole divided by the square of the denominator, which is equal to z plus I whole raised to 4. Take z plus I and e raised to iz common from numerator, then limit z tends to I, e raised to iz into z plus I into I into z plus I minus 2 by z plus I whole raised to 4. Cancelling z plus I terms and replace z with z tends to I, then e raised to iz becomes e raised to I into I into I into z plus I becomes I plus I minus 2 by z plus I the whole cube becomes I plus I the whole cube. E raised to I into I is e raised to minus 1 into I plus I is 2I minus 2 by I plus I the whole cube is 2I the whole cube. E raised to minus 1 into I into 2I is minus 2 by 2I the whole cube is 8I cube. Minus 2 is minus 4 e raised to minus 1 by I cube is minus I, then 8I cube becomes minus 8I. Cancelling 4 and 8, then we get e raised to minus 1 by 2I, which is equal to 1 by 2IE. By using Cauchy's residue theorem, 2 pi I into sum of residues minus infinitive to infinitive e raised to ix by x square plus 1 the whole square dx equal to 2 pi I into sum of residue is 1 by 2IE. E raised to ix is cos x plus I sin x. Then integral minus infinitive to infinitive cos x by x square plus 1 the whole square dx plus I into integral minus infinitive to infinitive sin x by x square plus 1 the whole square dx is equal to, cancelling 2I, we get pi by E. Here in this question we have to evaluate integral minus infinitive to infinitive cos x by x square plus 1 the whole square dx. So we compare real part on both sides, then integral minus infinitive to infinitive cos x by x square plus 1 the whole square dx, which is equal to pi by